Hey guys, welcome back. We're going to try some more examples on limits. In the previous video, I just did rational functions and I just factored when I got 0 over 0 and I rationalized and I combined fractions and so on. In this case, all I'm going to do is take a look at as x approaches infinity for a lot of examples. Before I do that, I want to just remind you guys of a couple of things. The graph of y equals e to the x looks like this. That's important. It's an exponential function. As x starts to increase, then the y increases. As x decreases or gets very, very small or approaches negative infinity, you go to 0. The natural log of x looks like this, okay? And so as you get closer to 0, it goes to negative infinity. As you move away from 0, as x approaches infinity, it actually becomes larger. I also just want to remind you guys of some algebra. 5 to the negative fourth means 1 over 5 to the fourth, which actually just makes it really, really small. 5, that should be what, 625, I guess? I don't know. Okay, so that's 25, 25, that's 625, yeah. Okay, it's very late, to be honest with you. Okay, so now I have this guy here, 7 to the negative infinity would just be positive infinity, even though I can't really put infinity. Okay, so let's start some problems and just remember these 4 things here. All right. I'm using some problems from Akuta Software, which is a website, and it's free, and you guys should check it out. They have some really nice things. Okay, now, in this case, and in all these cases, the limit as x approaches either infinity or negative infinity, okay? So let's see what happens here. When you are discussing the limit as x approaches infinity or negative infinity of a polynomial, all I care about is the highest on top with its coefficient, highest exponent, and the coefficient. Okay, so in this case, all I care about is x to the third. What would happen when I put a negative large number, negative to the third? Well, I would get negative infinity. I hope you guys understand that. Negative to the third power is negative, infinity to the third is infinity. Okay, now I have a rational. If you guys remember my video, what you have to do for rationals is you take the highest on top, highest exponent on the bottom, make sure you take its coefficient, and then you just reduce it first, so that's x over 4. Now let's plug in positive infinity. Well, infinity over 4 will still be infinity, okay? If you have a really large number and you divide it by 4, it's still really large. All right, the next one, let's see what happens in this case. So in this problem for number 9, you see that the square root of 2x squared plus 3 over 2x plus 3. So what we can take a look at is actually the highest on top is 2x squared, the highest on the bottom is 2x, but you have to take this square root with it. If you really think about it, square root of 2x squared is really square root of 2 square root of x squared. Square root of x squared is just going to be x, but we really don't know the sign of it right now. So before we do anything, we're going to see that this is as x approaches negative infinity. So the bottom part will give you a negative, okay? So that's the important part here. Anytime you have a square root, you have to see if it's going to be negative or positive. So basically, this is going to be this over this. And then we're going to see that x and x cancel out. And what happens here is because of this negative and because the original function looks like this with the square root, you have to compensate by putting radical 2 over 2. A negative. All right, let's try just a few more. All right, in the previous slide, I showed you guys that the natural log of x can go on to infinity, and this is x to the fourth. What you notice in this case is the natural log of x, if you guys remember, it keeps growing, but the problem with it is that it grows very, very, very slow, okay? X to the fourth grows way faster. So the natural log of a huge number, I know we can't put infinity in there, over infinity to the fourth, the bottom part is growing much faster than the top part. So it's almost like saying, hey, I'm at 5, you're at like 1,000. I'm at 6, you're at like 10,000, and so on. So it's one of those things. So basically, you should always see which will grow faster, the bottom or the top? And so in this case, it's going to be this guy here. Exponentials will grow faster than logs, okay? So that actually makes this whole thing go off to 0. 0 plus 1 is 1. Okay, here, the limit as x approaches infinity, e to the x, if you're going to put an infinity here, this is going to take off. So that's just infinity, okay? We can try this one here. Number 6, this guy here, the highest on top is him, the highest on the bottom is him. If you go to reduce him, he becomes 2x over 3. You try to plug in infinity. 2 times infinity is huge, divided by 3 is still huge, so that's this guy. Now let's try number 8. The highest on top is 1x to the first, the highest on the bottom is 2x squared. When you reduce that, you get 1 over 2x. If you try to put infinity into the x, 1 over a really, really, really large number. If I give you $1 out of a really large number, I'm basically giving you nothing. So that's this guy here. You're going to sort of have the same idea here. The highest on top is radical 2x squared. The highest on the bottom is 4x. The coefficients are actually radical 2 over 4 because the square root of x squared is just x, and then they match. Okay, so they just cancel each other out. But once again, it's negative infinity, so it's really like a negative. All right, 12 and 14, and then we're done. So put infinity here. What would happen? E to a negative large number is the same thing as doing 1 over e to a large number. That's what I was trying to show you guys here. Okay, so e to a negative large number is 1 over a really large number, which basically is 0. This guy goes off to 0. That's important. 0 minus 1, that limit is negative 1. Now put a negative infinity here. Negative 4 times negative infinity is going to be positive. E to a positive large number is just going to be positive infinity, but then we have this negative right there. So that's what you do in that case. And that's how we do limits as x approaches infinity. That involves e, natural log, rationals, polynomials, and so on. So come back for the trig limits, which is in the next video.